Welcome to ACPA's bi-monthly webinar. This is our August webinar. As part of Concrete Pipe Week, we're excited you're going to be a part of that with us. And today we're going to be talking about innovations in concrete pipe. We have a very expert panel with us today, and I'm excited they're going to be joining us. And I'm going to go ahead and turn it over to Heather, who is our first presenter. Heather?
Thank you, Kim. I appreciate you guys. Thanks, Michael, for that introduction. Hey, welcome, everyone. We are so excited to be presenting during Pipe Week. What a cool week for our industry, and to talk about innovations and kind of get a brag about our industry. That's really fun. So if you haven't heard, obviously we're talking about the innovations that have occurred within the industry regarding concrete pipe and box sections. So before we get started, I do want to introduce the other presenters that are on the line with me today. I'm Heather Christensen. I'm there on the left of this slide. My position is I'm the technical marketing manager for Geneva Pipe and Precast. We are a Northwest pipe company. We're located in Utah. On the line, I've got Margarita and Ashley. Do you guys want to introduce yourselves?
Sure, thank you, Heather. It's Margarita Taco. I'm the technical resources engineer for the American Concrete Pipe Association, and I'm located here in Irving, Texas. Ashley?
Hi, I'm Ashley Isaacson. I'm a technical resource manager with Forterra Pipe and Precast. I am located at our Grand Prairie facility, which is right outside of Dallas.
Wonderful. Thanks, ladies. I really appreciate that. While you're only hearing from the three of us today, I do want to point out that this presentation and the resources that came along with it were put together by a whole team. So that team is listed here. And on top of that, we actually got a lot of additional help from the industry members, industry experts that shared their knowledge about this industry, which really helped us develop this presentation and find all of these cool things to brag to you about today. So let's go ahead and jump into it. What we're here to talk about today is innovation. So I want to start this presentation off with a poll question. Make sure you guys are engaged, make sure you're listening, get some of your input. The poll question today, Kim, if you want to launch it, I think that you have the ability to launch that poll question.
Yes, it's coming your way. Just one second. Let me get that launched.
Thank you.
Okay, so first poll question is, of the following words, which comes to mind first when you think of the word innovation? Your choices are change, invention, improvement, breakthrough, or optimization. And if you have trouble clicking on this, it won't let you click, resize your window, either full screen or not full screen, and that usually helps resolve that issue. Give everybody just a minute or two to answer that. Looks like we have 82% of folks who have voted, and they're still coming in. So Heather, I'll give them just another second.
Awesome, thank you.
Okay, so Heather, we had 7% said change, 16% invention, 40%, which was our largest, is improvement, 24% breakthrough, and 13% said optimization.
Awesome, that's the results I was really hoping for. This is more, for me at least, kind of a social test. I think that the definition of innovation, if you look on Webster Dictionary, it basically says that innovation is a new idea or method or strategy. And to a lot of people, that's what it is, right? So I'm really happy that you guys noticed that it should be an improvement, something better than what was there before. Many people think of it just as something new, something different. And while that's half of the definition, I do want to introduce an alternate definition Webster Dictionary would have, which is a notable change in a product or method that creates new value. And the new value is really the key that we're going to talk about today. New value in the form of convenience, quality, safety, cost savings, sustainability, and or efficiency. So any of all of those topics or any of them. But the key point is that it needs to introduce new value. We don't want to just change things to change things, right? Some people might have the mentality that why change things at all? Why invest time? Why invest money? Why invest the effort in changing things? Well, to those people, I would explain that innovation really is a great tool to fuel progress in our society. Innovation has changed the way that we live and the way that we interact with each other. It's led for breakthroughs like electricity, automobiles, cell phones, airplanes, flight, computers. It's allowed us to talk together today in this webinar, and I think that's really cool, and we definitely need to emphasize it. The government is putting it first right now. A lot of companies are putting it first. It's emphasized everywhere, universities, you're hearing it all over. It's a major buzzword right now, and I think it's really important to advance our society with innovation. But I do want to ask you guys is, do you ever think of the word innovation and do you relate it to risk? So when I researched a lot about innovation, I can't find anywhere online or in the resources I looked through that innovation has any risk associated with it. And I think that's an important thing to discuss as we're talking about the word innovation and how it affects us in our marketplace. I do want to talk about the risks involved with innovation in the form of a couple different examples that probably many of you have already known. The first example is a product that you guys probably all have within 1 meter radius of you, 1 meter foot. It's cell phones. Okay, so this is a brand-new cell phone that was introduced in the marketplace. The Galaxy Note 7. It was marketed for an improved storage capacity, a larger screen, a better battery life. It was actually better than most cell phones in the market at that time. It was marketed for all of these benefits. But after it was implemented, it became most widely known for its major disadvantage. And that disadvantage was that it would spontaneously burst into flames and sometimes explode. And so that put people's safety at risk. It wasn't really noted, or people didn't realize that that was a risk before it got implemented widespread within society. And so that's something that was a risk about an innovation. Another one that's an example that I'm sure all of you have heard of is Freon. Freon was marketed as a miracle compound. It was supposedly going to be a safe alternative to other harmful refrigerant chemicals. And it wasn't until about 40 years into the use of Freon widespread in society that we found that it was actually causing extreme destruction of our ozone layer. Okay, so that was a big deal, and environmental implications with that product led to a lot of destruction, and now it's actually banned. Another one is an aircraft manufacturer that changed the design of one of their airplanes. They increased the size of their engine in that airplane, and the benefit that they were looking for there was to improve the fuel economy, improve fuel efficiency. Now, with that change, they also implemented it in a way that didn't change the cockpit design. So the benefit to them there was that they didn't have to implement a lot of training for pilots. They were able to push that innovation through real fast. And the trouble with pushing that innovation through really fast without the documented research, without it being proven, it had a lot of oversights in safety. And those oversights in safety led to death of hundreds of people. And so it's really important. That's one of the topics I want to talk about today, is that innovation can introduce risk. And you got to think about that when we're promoting innovation in our society. While it's critical that we push innovation and we advance our society, it's also critical that we think about that in a form of ethics, right? We want to make sure that we're making ethical choices about the products we're innovating and how we're innovating those products. And one of the key elements of our society, which I would say it's the most impactful to us and that we want to have the most responsible innovation, is our infrastructure. Why would we care so much? I mean, infrastructure is something that we all rely on every day. We've relied on it to get to work probably this morning. If you're working in your office or at home, we're relying on it right now to communicate. And so it's so important to push responsible infrastructure innovations. How can you avoid risks when it comes to innovation, though? Is there a way to adequately point out that something might have a higher level of risk associated with it? We like to think about this in the form of innovation phases. So if you're thinking about a product and the phases of innovation that it goes through during its lifetime, you might be able to break that down into 3 specific phases. So the first phase would be invention, okay? So invention is the phase where that product didn't exist yesterday and now it exists. So that's where that product is inherently new and it's developed then. The second phase is upgrade. So upgrade is when they introduce significant alterations to a product in order to improve it. And then the third phase is optimization. That phase is that product has existed in the marketplace for some time, or it's been researched for so long. And at that point, they figured out all of the things, they fine-tuned that product to be what it is, and they're happy with it. And now they're only just introducing micro enhancements. And what I think of that is they're small but measurable differences that improve the application of that product. And so when you think of like an example I like to think about when I think of the optimization phase is a parent watching their child grow up. So when you're the parent and you watch your child grow from a baby all the way up to a grown man or woman, you don't really get to see all of those little individual changes that are happening on an everyday basis. Because they're going slow, they're going steady, you don't realize them right off the bat. And that's kind of the way the optimization phase of product development works and product innovation. And an uncle, maybe they've been gone, maybe they come and visit after 5 or 10 years and they see the change in that child and to them, it's night and day difference, right? But to the parent, they're like, oh yeah, you know, they grew up. That's what we've seen for the last few years. And so it's really, you don't really see them right off the bat, but there is a measurable change, especially over time, that you can notice from that. Now, when you think about the phases of innovation, I do want to point out that each one of these phases comes with a varying level of risk. So when we apply the risk and we think about the risk of these phases of innovation, the invention phase is obviously going to be the most risky, because at that point, you're treading through waters that are basically unknown. You don't know that product is, it's not known, it hasn't been used, you haven't been able to work out all the quirks. And so ultimately, you're going to have more risk associated with that phase. Whereas in the upgrade phase, if you're changing an entire feature of a product, you might impact some other features of that product, okay? And so when you do that, there's a level of risk associated with that. And I would say that's medium level of risk. And in the optimizations phase, I would say that's the lowest level of risk, because at that point, it's been used for so long, it's so widespread, and you're changing things on a micro phase. And they're making benefits, and they're small and measurable, but they're not changing the entire product overnight. And so you basically know every risk that's associated with that product already. And that's where I would put concrete pipe. So our industry existed for so long, it's well past the invention and the upgrade phase. While there has been major upgrades that have happened in time, really now we're in the optimization phase, and we are fine-tuning these products to be safe and reliable for our industry. So at this point, I do want to turn the time over. I mean, at the first half of this presentation was discussing innovations as a general topic and the risks associated with innovations. But at this time, let's transition over to Margarita and Ashley, and they're going to talk about all the specific innovations that the concrete pipe and box culvert industry has done. And it is so cool. So we'll get a little bit technical, but it's really fun to brag about all these improvements that have happened within our industry.
Okay, thank you, Heather. So in this presentation today, we will go through an overview of how concrete mix design, reinforcement, joints, quality and production, standards and design aid, installation, and the research have evolved through the time. At the very end, Ashley and Heather will highlight the overall innovations of the precast concrete pipe industry. Now let's start with concrete mix design. With concrete being one of the most used construction material in the world, advancement and innovations are happening continuously. Like Heather mentioned, like when my son grows every day and I don't really notice, when my mom talks with him, she always tells me how much he has grown up. So it is a continuous advancement that has been evolved through the time. So in the past, the mix designs were meant as a process of mixing some water with some cement and aggregate, which is not the case anymore. Currently, mix design is like a science. By the way, I do love science very much. So nowadays, a mix design, as I'm showing here in the presentation, is defined as the process of determining the required and specifiable characteristics of a concrete mixture, such as intended use, environment, and other variables, which can be defined as its fresh or hardened concrete properties and inclusion or exclusion of specific ingredients. In our industry, the mix design is carefully performed at the plant level, starting with investigating all raw materials and defining how they react with each other and how they affect the mix. Concrete mix is then put at the plant, and it is defined if the mix works or if there are adjustments that need to be made. To serve the construction needs, innovation in mix design aims to broaden the versatility of concrete, allowing for a wider range of applications, such as improved production rate, sustainability, aesthetics, product cost, and service life. Next, we will go through alternative concrete ingredients such as admixtures and some supplementary cementitious materials, which is beyond what aggregate water and cement. So let's have a look on admixtures. So it was not until the mid-1970s, as I'm showing here, when a widespread use in concrete pipe industry kicked off. Commonly used admixtures in the industry are water reducers, accelerator, corrosion inhibitors, lubricants, and viscosity modifiers. If used properly, these chemical admixtures can provide a variety of benefits to both pre-cure concrete properties such as workability, setting time, and producing non-segregating mixes, as well as post-cure concrete properties such as strength, durability, and resistance to degrading environments. These benefits are passed to the end user in the form of expedited product availability, improved quality, and extended service life. Now, on the supplementary cementitious materials, among of many improved concrete product properties, such as high strength, durability, and chemical resistance, the use of SEMs in precast concrete allows for environmental advantages by promoting the use of recycled materials. Using SEMs in concrete mixes, you actually create a low carbon cement mix, since the materials that will end up in the landfill are used in the mix. Some of most commonly used SEMs in concrete pipe are fly ash and slag cement. I will be including in the chat box a link with a video that will shows how LafargeHolcim, one of the biggest cement producers in the world, what they do to reduce carbon footprint. You will see that in a couple of minutes. For more information on which alternative concrete ingredients can be used in the concrete pipe industry, you should consult with the local manufacturer. Now let's have a look on mix design. There are several methods that a concrete pipe and boxes can be produced, but the mix designs can be somehow categorized into main categories. A zero or low slump is the middle figure that I'm showing here, which is a dry cast concrete, and a high slump concrete where wet cast and SCC self-consolidated concrete belongs to. So in all cases, our industry uses all of these three mixes, and in all cases, the raw materials are combined in a systematic manner using quantities and proportions that meet the requirements, while taking into account local material availability and compatibility. Concrete pipe is not only made to convey water, it's also made to provide for long-lasting and sustainable communities. So we do support local available materials. What makes our industry unique is that there is a high level of consistency in batching and testing of the mixes. So it's the same plant personnel performing the same activities every day, either that's batching or testing. So the whole procedure offers consistency and repeatability. One more advantage of the precast concrete pipe is that the production is performed in a controlled environment without being affected by weather or other variables. Now let's take a look on wet cast. To those that are not familiar with wet cast, it is what is thought of when we hear the word concrete. Manufacturers of precast concrete pipe use various mix designs, as we covered before, to improve the efficiency, constructability, and quality of their products. The mixes can be designed for higher strength in order to accommodate the market demands, or for increased flow, which aids the concrete placement in certain structures for forms that are for concrete, which is hard for concrete to reach. So these are not only mixes, of course. Mixes can be changed based on application. Now, on the dry cast concrete, a definition of the dry cast concrete can be found on ASTM C1837, and it is mentioned that it's a very low slump or zero slump concrete that requires continuous and intense vibration, and the forms which is used to consolidate the concrete, enabling the forms to be removed from the product immediately. The first recorded installation of dry cast concrete reinforced pipe in the United States happened in 1906. Well, these pipes were made by placing circular rings of reinforcement into forms as the dry mixed concrete was done by hand. Impressive, right? Now, through the years, with all the advancements that have happened in automated machines for packing, vibration, and curing, has allowed for a wide variability of applications, with a great example of increased dry cast production for box culverts in early 1980s. Now, Ashley later will go through the production, innovations in production, but as you will see here in the photos, there are freestanding pipe and boxes that are just compacted and the forms are immediately removed. I was amazed myself when I first went to a plant tour and seeing how quick the forms were removed. So overall, the use of dry cast concrete allows for a speedy production rate and optimal use of plant footprint and resources. This benefits everyone since the products can be immediately available and fit the tight schedules and fast deadlines. So the self-consolidated concrete is the last that I will be talking about at this moment, which according to ACI Committee 237, it's a highly flowable, non-segregating concrete that can flow in the forms under its own weight and without any mechanical consolidation. So the applicability of SCC must be evaluated on a plant-by-plant basis based on material compatibility and local specification. One of the most impactful benefits of using SCC is that the elimination of vibratory compaction, which allows for safer and more sustainable production for highly congested reinforced structures. It is recommended to consult with local producers and see what the specific project requirements are and have a discussion on which mix is used. Now, I do have a poll question for you. Kim, if you can load that. So how soon can forms be removed after compaction in dry cast pipe?
Okay, that's been launched. So your options are, can they be removed the next day, within 1 hour, 30 minutes, or immediately? Margarita, 13% said the next day, 22% said within the hour, 8% 30 minutes, and 56% said immediately. Back to you.
Thank you for taking the time and responding. I'm glad that most of you got this correct. As we mentioned, the forms can be removed immediately. I would highly recommend that you contact a local producer to set up a plant tour so you can see yourself how this production is being made and generally see how the producer produce these pipes and boxes. Now I know we are going through the social distancing and other stuff, but our industry has been very innovative for one more time, offering virtual plant tours or drive-through plant tours that can help you with being part of these plant tours. So I'm adding to the chat a recorded virtual plant tour link that was held this Tuesday as part of the Concrete Pipe Week. So you can see yourself how the plant tour went. Now, Ashley, back to you.
Thank you,
Yeah,
Margaret.
right before Ashley goes, so just to show you guys where Margarita is talking about, in your chat log is where you're going to find those links that Margarita is going to put there. So she's going to put up a video of how cement producers are being innovative and lowering their CO2. And then also a link, if you missed our plant tour on Tuesday, you can catch it at the link she's going to put up there. So thanks, Margarita. Go ahead, Ashley.
All right. Thank you, Margarita. So I'm going to be discussing how the reinforcement in RCP and box culvert have changed over the years. So how have they been optimized? What innovative changes have occurred? Well, there have been changes, and they include optimizations made to steel areas, increased quality and performance of the reinforcement, as well as innovative advancements in the technology used to manufacture the reinforcement. So as you can see, over the course of the first 100 years that reinforced concrete pipe has been around, several changes and advancements have occurred. And today, for the sake of time, I'm just going to talk about a few of these. So let's start with the development of ASTM C76 and C75 in 1930. These were the manufacturing standards for reinforced concrete sewer and storm drain pipes. Having these standards allowed pipe manufacturers to have the ability to produce consistent and quality pipe. And then, as you see, in the 1960s, automated cage machines came on the scene, and they do exactly what it sounds like. They allow the manufacturer to replace a time-consuming process with an automated method of round cage production that was both faster and safer. Another important milestone occurred in 1967, and that was a reinforcement optimization that was brought on as a result of testing the reinforcement on a quadrant design basis. And the results of this testing allowed for a reduction in the reinforcement by up to 43%. And these provisions were then added into ASTM C76 in 1970. So as you can see, over the next 50 years, new standards were being developed and a heavy amount of research was being conducted. And the purpose of the research was not only to optimize the steel areas in the product, but also to better understand the forces that buried pipes are subjected to. And these thrust forces were then analyzed in a finite element program, and the research was published in 1984. So with this information, we were able to develop the 4 standard installations. And another result of this research was an optimized 3-edge bearing design that led to a reduction in the inner to outer steel cage ratio. The last reinforcement topic that I'll discuss today is the development of AccuCage, which is a method of producing reinforcement for box culverts. AccuCage provided a way to produce welded wire reinforcement with 2 wire sizes in one direction, welded to another wire size in another direction in very precise spacing at various lengths. This advancement has allowed for the use of exact or near exact areas of steel as required by the structural design, which almost eliminates the practice of oversteeling. So, as you can see, there have been a lot of optimizations and changes that have occurred to the reinforcement of our products over the years. Back to you, Margarita.
Thank you, Ashley. Next, we will talk about joints. So we saw how concrete and reinforcement have been evolved through the time. Now let's see how joints have been evolved. So the joints have seen great improvements over the last 30 years, and the advancements here are related to, of course, enhanced performance, meeting different sealing requirements. That is their job, right? Increased performance on resistance to infiltration of groundwater and backfill material, resistance to exfiltration of sewage or stormwater, ability to accommodate lateral or longitudinal movements, continuity and smooth flow line, and ease of installation. On the next slide here, we will see how few of the most significant joint options have been developed over the time. Starting with flexible sealant joints, since mid-1950s have been used broadly since then, specified by ASTM C 1919, which defines the composition and performance testing requirements for preformed butyl sealant. The next one is the O-ring gasket joints. They were developed as well by mid-1950s. The O-ring rubber gasket joints provide optimal sealing, allowing for increased external pressure resistance. Next is the offset joint. The first offset step joint was introduced in 1972, which improved the ease of manufacturing and gave rise to a variety of different gasket profile shapes. Next is the pre-lubricated gasket, which was first introduced in 1989, as I'm showing here. The gasket does not require lubrication or equalization during installation. All of this allows for an easier, quicker, and more error-free installation, which will save time and money during installation. Next, we have rubber gasket joints for shaped concrete pipe and structures, were developed in the late 20th and early 21st centuries. These gasket joints became available for box sections in 1995, for elliptical pipe in 2000, and for arch pipe in 2004, as I'm showing here. They do provide leak-resistant joints for the boxes, pipes, and arch pipe and elliptical pipe. Now, except from these advancements that we discussed here on the joints, there have been other innovations such as tools and methods that are used for measuring equipment and finished products, which allows for better quality control. Now, Ashley, back to you for innovation in product and quality control.
Hey, Margarita, we had a question for you on that one, on joints.
Mm-hmm.
So the question was, what joints or gaskets should be used for which applications?
So yeah, that does depend. We do have different joint requirements and different specifications that define what joint requirements can be used. So it depends on the requirement of the project and the specifications that we offer.
Great, thanks, Margarita. I also had, Ashley, one that I missed back on reinforcement for you.
Okay.
And that's, is composite rebar allowed for use in RCP and box culverts?
That I will have to defer to others. I don't believe it's a part of C76, which is our manufacturing standard.
Yeah, by composite, what came to mind with that question was epoxy coated. We don't typically use epoxy coated. There may be some sanitary applications where a few of our manufacturers might use that, but certainly not common.
Mm-hmm. Okay.
Okay.
All right. Well, now I'm going to go over innovations and advancements that have happened in production and quality, and these innovative changes that have occurred over time with respect to these areas. And I'm going to start by talking about product shapes and sizes. So for the first several decades of its existence, precast reinforced concrete pipe was round. That was the only option. Then in the 1950s, arch and elliptical pipe were introduced. So just think about all of the new applications that this opened up. Suddenly there's a good solution for high flow, low cover situations that could have been problematic before this. So another very popular option for this situation is box culvert, and it was developed in 1964 as a way to provide an alternate to cast-in-place structures, and it had the added benefit of also having a much easier installation. The ASTM standards for box culverts then followed in 1974 and 1976. Other advancements outside of product shape include large diameter pipe with different joint designs that allow for a variety of applications, and Margarita just talked about those earlier. Another area that has experienced a huge amount of change over time is the production of precast concrete pipe. So prior to 1916, all of the pipe was produced by hand. Can you imagine what that process looked like? Talk about time consuming and labor intensive, right? Well, just like most other manufacturing industries, the concrete pipe industry has gone through significant changes in the way that concrete pipe and box culvert are produced. Automation in precast plants has evolved over the years, which has allowed the industry to respond to the increased demand, while at the same time increasing the quality, speed, and safety of production. The introduction of automation began in 1916 with the development of tamp machines, as you can see there. And then by the 1950s, the Senbiro process was developed, which utilized a combination of centrifugal, vibration, and roller compaction to produce the pipe. Then you fast forward to today, and manufacturing plants have the ability to be fully automated, which creates a much more efficient, productive, and safe workplace. So the last area in this section that I'm going to discuss is quality. And in an effort to improve the overall quality of all concrete pipe products throughout the nation, the American Concrete Pipe Association's Quality Committee developed the QCAST program. So from 1992 to 1997, the program was being developed, with the first standard published in 1998. And it is an ongoing quality assurance program that consists of unannounced audits by a third-party firm, and it covers the inspection of materials and finished products, handling and storage procedures, as well as performance testing and quality control documentation. Manufacturing plants can be certified in storm and sanitary sewer pipe, box culverts, three-sided structures, and manholes and precast structures. And each year, the QCAST manual and criteria for certification and recertification are updated in order to conform to the most current practices. So these are just a few of the many innovations that the concrete pipe industry is using to improve the quality and production capabilities of our products. Back to you, Margarita.
So now we will be going through standards and design aids innovations that have happened in our industry. So by development of national utilization of standards and design aids, the variability in product design and production has somehow eliminated, which in turn allow for a united advancement in the industry. The use of standard and design aid allows for a consistency in material use, production efficiency, and quality. As Heather explained at the stages of innovation earlier, the risk is reduced by being consistent. So consistency in production lowers the risk associated with the product. One of the first committees that is focusing on the development and advancement of the concrete pipe is the ASTM C13 on concrete pipe, which was first formed in 1930, very long years ago. Since then, though, C13 has expanded to a diverse membership of over 225 technical experts from 11 different countries and manages more than 65 standards, which are related to sewer, culverts, irrigation and drainage system, low pressure pipe, factory-made compression, and self-energizing joints and other products. One of the first standards was developed by this committee was back in 1917 on non-reinforced concrete pipe. And among the most recent is ASTM C1840 for inspection and acceptance of installed RCP, and ASTM C1894, which is a guide of microbial-induced corrosion of concrete pipe products. You can find the full list of when each ASTM standard was developed on our report. To date, a variety of standards have been established through professional involvement in organizations such as ASTM. Others are the Canadian Standard Association and the American Society of Civil Engineers, or ASCE, American Railway Engineering and Maintenance of Way Association, or ARIMA, in the American Association of State Highway and Transportation Officials, or ASHTA. I got this corrected. These standards provide a variety of subjects related to, but not limited to, guidance on design, manufacturing, installation, testing, and others. Next, we will see how the design tools and programs that are offered by ACPA have been evolved through the time. So design tools and programs have been developed by the most experienced industry members to assist manufacturers that produce the product, as well as engineers that design them. FIDA, it's a finite element analysis program, which was developed in the 1970s from research sponsored by ACPA, which aided the understanding on how loads are distributed on an installed concrete pipe. Very innovative for that time. Now, pipe car and box car were both submitted to the Federal Highway Administration, or FHWA, in 1982, and they enabled a quick and efficient design that can be done by designers with varying experience level. Another design software that was developed by the concrete pipe industry was PipeHack software in 1996. The design software can conduct 3-edge bearing design, cost analysis of pipe envelope, and life cycle analysis. Now, Ericsson Calvert in 2010 was developed for box culvert and load rating, box culvert design and load rating, and Delton Pipe in 2017 for reinforced concrete pipe design, and both replaced boxcar and pipe car that I talked a little bit earlier. Other tools that are offered by ACPA was fill height tables in 2009, which allow you to easily define the strength of the pipe in less than a minute. Pretty great, right? Other tools such as hydraulic design that I'm showing here and cost comparison are others, and other design tools contribute to the development and advancement of the industry. Now here, I do have another poll question for you. Kim, can you load that?
Yes, coming your way.
Thank you.
Okay, so how often do you use ACPA design software and other tools like fill height tables? Do you use them daily, once a week, once a month, or rarely? Okay, I'm going to close that one, share it with the audience. So we do have the majority of folks, Margarita, 20% using once a month and 67% using them rarely, with only 13% daily or once a week. So good to know. I think we can certainly help you guys out with some of these tools and make your jobs easier.
Yeah, I would say for those that have been using them, I hope that they experience the benefits that this tool offers. And for those that have not, please, you can contact us here at ACPA and you can learn more about how this software can help you. Now, Ashley, back to you for innovations in installation.
All right, thank you, Margarita. So now I'm going to talk about installation, and this is another area where numerous innovations have occurred. And one way this is accomplished is through research that results in the development of installation standards. So why are installation standards important? Well, they allow for consistent and proven high quality installations across the nation. So earlier in the presentation, when I was discussing reinforcement advancements, I mentioned the research conducted by the ACPA and Hager, which resulted in the development of the 4 standard installations for RCP. And these were incorporated into ASCE Standard 15 in 1993, and then into ASTM C1479 in 2000, which is the installation specification for concrete pipe. These standard installations offer versatile, conservative, and quantifiable installation direction for both the designer and the contractor. Then in 2011, the box culvert installation standard was developed, which is ASTM C1675, and additionally specifications with criteria for evaluating both the pre and post-installed condition for precast concrete products was developed. AASHTO R73 is a standard for the evaluation of the products in the pre-installed condition, where ASTM C1840 is the standard for evaluation of the products in the post-installed condition. So now let's talk about exciting and innovative installation techniques. And while there are so many installation techniques that have been developed that are both exciting and innovative, a couple that I'm going to mention today are trenchless installation and the use of the flooded backfill process. So trenchless installation is the use, trenchless installation has been around for over 70 years in the US. And while this isn't a new process, there have been advancements made to this process over time, and it's becoming more and more common due to the many benefits that it brings, such as less environmental impact, reduced construction time, and the ability to span underdevelopments or waterways. And concrete pipe is an exceptional product to utilize in trenchless installation due to its high compressive strength and durability. And another method for installation is the use of flooded backfill. And it was developed in 2005 by the Iowa Department of Transportation, and it involves using floodable backfill material that is compacted by flooding the backfill with water. And I know this seems like a simple process, but it results in a high quality and potentially less expensive installation. So great job, Iowa DOT, for coming up with innovative ways to produce high quality installations of RCP. And another point to note is that both of these methods allow for reduced or zero trench entry, which increases the level of safety of the installation process. Back to you, Margarita.
actually, before we head to that section, we have some questions that are coming in that are really solid here. Kind of try to answer a few of these. They're coming in with regards to the cost of installation RCP versus plastic. I think that there's just some confusion about that. In some cases on the front end, it might look a little bit higher than one or the other. Can you guys just address some of the costs that the cost differences that come between RCP versus plastic?
Okay, yeah, I can address what comes to my mind, and that's going to be a difference in backfill requirements, the structural backfill required to complete the structure for a plastic pipe installation versus the requirements for a rigid pipe installation. So when you have that reduction in backfill, structural backfill cost, then that will definitely help bring down the cost of a rigid pipe installation.
Yeah, Ashley, I think you nailed it. You know, with concrete pipe, 90% of your structure gets delivered to the job site, and 10% or so is involved in the installation of that pipe to build the overall structure. With plastic pipe, the reverse is actually true. You may get 5 to 10% of your strength from the installation, from the pipe itself, and the rest comes from the construction of that backfill. And so it's much more rigorous to install a plastic pipe correctly. And there's where your cost difference comes from. So if all is equal and both are installed properly per the national standards, you actually won't see a big cost difference in the two products.
Oh, sorry, I was muted there for a second. Another thing I would note on top of that as well is the time involved with installing the two different products, right? Time equals money, and so if it's more compaction, more steps needed, then you're introducing more money with the cost of that installation. So materials and then time.
All right, great question. I'll turn it back over to Margarita now.
Thank you. So last but not least, we will go through innovations made available via research. As Heather mentioned earlier at the beginning, innovation fuels progress and the research fuels innovation. Well, I will add to that that the research is the motor of innovation. That is where the progress starts, right? So all of the innovations described until now have been made available via the concrete pipe producers providing efforts to support the innovation and advance the industry. So one of the understood advantage of the concrete pipe industry is that it is made up of hundreds of different producers in various environments with different backgrounds and areas of expertise. Each company is incentivized to innovate toward their own path based on market demand. So the innovation that prove to be effective over time are then adopted by other producers, and that cycle continues. Besides the routine improvements almost, though, concrete producers adopt on a regular basis. ACPA formed a specific committee called the Research Committee back in 2008 to lead and encourage the collaboration efforts between RCP manufacturers to promote innovation. So we have all been asked, or some of you may have asked, where is the concrete pipe industry headed next? What is the next big innovation? Well, to answer these questions, we need to look no further than just a few of many ongoing research projects that have been undertaken by producers and by the ACPA Research Committee, which they are all seeking to improve the quality and efficiency of the RCP. The first such example is the fiber-reinforced concrete pipe. While the fibers, either synthetic steel or glass reinforcement fibers, have been used since 1960s, but the widespread popularity was gained the last decade. Currently, the RCP industry is looking at ways to further improve the durability and the testing of products by the use of fiber additives. The use of fibers in the industry could lead to a lighter weighted product, making handling and mobilization more economical. Another research on mitigation and microbially induced corrosion, which is a concern for concrete pipe and manholes, used in sanitary sewer applications. Complete and ongoing research seeks to standardize the evaluation process for effective microbial-induced corrosion. This will result in improvement performance and life expectancy for concrete products in sanitary sewer environments. So as research continues to remain a priority for ACPA, responsible innovation is what we aim for. Ashley, back to you.
All right. Thank you, Margarita. So we've talked a lot about the changes that have happened over the entire 100+ years that reinforced concrete pipe's been around, but as you can see, there are still continuous advancements in this industry that are being made. So looking at the timeline over the last 15 years, you'll see that optimizations such as better testing methods and measuring equipment have been developed, and this has helped to improve the quality of precast products across the country. There's also been an increased focus on manufacturing safety with the development of the ACPA Chairman's Safety Awards. And this program recognizes innovations in manufacturing safety each year, and then these innovations are shared across the industry. Also, research on box culvert was conducted in order to better understand the fatigue and shear behaviors, which led to reductions in the required steel. And in 2010, the first curved microtunneling project in the US was constructed, which helped solidify the ability of complex curved projects to be installed using a trenchless method. So over the last 10 years, new ASTM standards have been created, and also quality-related programs have been created or added to. So as you can see, quality and safety are big items that receive a lot of focus, and that's because at the end of the day, as Heather mentioned earlier, we need to make sure that all of these optimizations are done in a safe way and provide a safe and quality product to the end user. Over to you, Heather.
Thank you, Ashley. Thank you, Margarita, for sharing all these cool advancements that have happened in every aspect of the industry. Everything from the production methods we're using, from the concrete mix designs we can tweak to fit all the different variety of applications of these products. The shapes, the joint design, all of these things have improved to make our product safe and reliable and sustainable. And while we weren't able to talk about all of the innovations that have happened throughout the industry over the entire lifespan of the product, we did point out quite a few that we like to brag about. And I mean, if you look at this timeline here going across your screen, these are all of the many, thousands of innovations that have occurred, and they will continue to occur, but we have to do them at a rate that we can make sure that research is put first, and that these tests are done and that they are proven before they're implemented widespread. So we can put the safety of our people and the environment first. So in top of this presentation, I do want to point out that there's some additional resources available to you guys. We have produced a handout that basically summarizes a lot of the things that we talked about here today, and then another document that's a written report. And so if you're really interested in what we've been talking about and you want more information, this document is probably at like 35 pages long. It goes deep dive into all of these very specific innovations and how they've impacted our end users of these products and how they've improved the industry as a whole. So those documents will be made available to you, I believe, later on the ACPA's website. Kim, will we be sending out an email with the location of these documents with the PDH credit, or how will we make these available to everyone? Oh, Kim, you're muted.
Thank you. We will send those out as soon as we push out PDHs, and then they'll also be posted to our website. If you lose that link, you'll be able to find them on our website.
Awesome. Well, thank you guys so much. At this point, we want to open the time up for any questions you might have. Oh, actually, just kidding. We actually have one last poll question. So Kim, if you want to go ahead and launch that poll question. When was the last time your drainage specifications were updated?
Okay, so the answer choices you have are: we just completed an update in the past 6 months. It's been 1 to 2 years ago since we've updated our specs. 3 to 5 years, or 5+ years for drainage specifications. As we're talking innovations, there may be some efficiencies that can be gained within your specifications. if it's been a while since you've updated those. So we're kind of curious how long it's been.
And as we've talked about all of these improvements in the industry, we do want to point out that with specifications as well, those improve over time. Standards of design, standards of installation, as we learn more about products and we learn more about the infrastructure, those things change. And so it's important to update those specs consistently.
Yeah, great point, Heather. So just the results of that polling question, we had 16% that have done them within the past 6 months. That's awesome. 32% 1 to 2 years ago, 22% 3 to 5, and 31% 5+ years ago. So quite a mixture and when those have been updated, which brings me to our final polling question, which is ACPA provides specification reviews. So if it has been a while for you guys, we'd be more than happy to help you as the engineering community to review your specs and suggest changes for concrete pipe and make sure that they are the most efficient for you and your taxpayers that you're working with. So just curious if you'd like to take advantage of this service that ACPA provides.
This is something really cool that I love about the industry is that, you know, we're always so intrigued and we're staying up to speed on all of the new updates that are happening with standards, with all of this stuff. And so to have us available to you guys at your service to utilize our expertise and help you keep your specs up to date such that you can save money and save time and installation, things like that. That's such a cool service that we will provide. So we're excited if you want to take it.
I'm just going to share those results. And we do have 30% of our audience today that would like a specification review, which is awesome. We'll be more than happy to reach out to you and see what we can do to help. So with that, maybe we can get to, I know we're a couple minutes over and I do want to respect everyone's time. So if you guys can hang with us just for maybe less than 10 more minutes, we'll answer a couple questions and then we'll close out with just a couple closing comments. So we had a couple good questions. One was, beside what design software would you recommend using for the fill height tables? And I was going to go ahead and post in the chat log where you can find our fill height tables. So I'm going to post that now if you are looking for those.
Thank you.
You can find them right there in that link. And another great question came in. Let me find it. We have a bunch of questions that came in. So I do want to note, if we don't get to your question during this, we will reach out to you following the webinar, someone on staff or one of our members to make sure all your questions are answered. But a great closing question came in. What is the average lifespan of RCP?
I don't mind taking this one. The design life is over 100 years. There's been product in the ground that has lasted more than 100 years. So in terms of design life, you can rely on this product for many, many years and generations to come. And so that's the design life. There's been proven circumstances. I believe, what's the oldest one installed and on record? What was that one, guys? What date was that?
It was in 1906 for the dry cast, and I believe there were earlier installations recorded as well. So yeah, I did wanted to mention as well that the proven life is more than 100 years, and that's what we see, that's what we go with.
And I'd like to add that proper installation and proper pre and post installation inspection, utilizing these national standards that we have, will definitely help ensure that that lifespan is maximized. So if you'd like more information on any of those standards, feel free to reach out to us.
Okay, fantastic. Well, thank you guys. Y'all have done an amazing job with this webinar. With that, again, thank you, Heather and Margarita and Ashley, for today and all your expertise. Thanks, everybody. Have a great day and stay safe.
Thank you for joining. Bye-bye.